Hello everyone and welcome back again to the linear algebra component of the Calculus and Linear Algebra series. In the last video we introduced this new topic, which was first order logic, and we also introduced this idea of a predicate, which is kind of the main thing on which first order logic is built. So much like in propositional logic, where everything is built on this idea of a proposition and a propositional variable, first order logic is built on this idea of a predicate and a predicative variable. Let's recall again, a predicative variable is a variable that takes values in the space of predicates. And then we said, much like in propositional logic, where we then talk about building our logic-based system and our logical connectives, we want to draw over that to first order logic, where we construct logical connectives, but now for predicative variables instead of propositional variables. And it was rather nice that we found out actually that all the logical connectives that were introduced in the propositional logic section can be drawn over to the first order logic section, and those can be used now. Instead of where we put in propositional variables, we now put in predicative variables. So before I move on to anything new, I just want to reiterate this point a bit like I did in the first set of videos, that what is the task of predicative logic? Well, it's really important to say that it's not the task of predicative logic to try and identify whether or not anything is a predicate or not. Much like in propositional logic, it's not the task of propositional logic to identify whether or not a particular sentence is a proposition or not. But it is the task of predicative logic to build a logic-based system around this idea of predicates. So now that I've kind of reminded that, I want to move on to this new idea and about kind of universal, existential, and uniqueness quantifiers. What these address is the point that I made in the last video about how to formalize particular statements that contain words like for all, or there exists a unique. So how can we formalize statements of that form? And it turns out we can do that in the context of first order logic, and that's because our kind of most fundamental piece that we're working with now is predicates, and predicates themselves run over a variable. So that means that we can kind of talk about some values or we can run over values of which that variable runs over. So let's look at our first definition here, and our first definition is going to be that of universal quantifiers. So let P of x here be a predicative variable. Then the universal quantification of P of x is the propositional variable P of x is true for all values of x in the domain of discourse. And we write the notation of this kind of upside down capital A. X, P of x, is used to denote this universal quantification, and we read that symbol, this upside down A, as for all, or we can sometimes say for every. So in other words, what we're saying here is our P is, our P of x is our predicative variable, so we think of it as a variable that takes values in the space of predicates. It doesn't represent a specific predicate, it represents kind of any predicate. And this x here is just the variable that kind of goes into the predicate, or into the predicative variable. So we've got a predicative variable that runs over the space of predicates, and that predicative variable is a function of another variable, and that variable takes values in the domain of discourse that is to be decided. And the universal quantification, effectively what it does is it takes our predicative variable and maps it to a propositional variable by putting the word for all in front of that predicative variable. So we can, in other words, think of universal quantification as a function from predicative variables to propositional variables. And we'll see in a moment, what kind of statements might arise that look like this. And as you might expect, we can now move over to our next one, which would be an existential quantifier. In a similar way, right, we now have a predicative variable, P of x, is a variable of one function. And the existential quantifier of P of x is the propositional variable, and we say there exists an element x in the domain of discourse such that P of x is true. And again, we use this notation, but it's kind of like a capital E now backwards, x P of x, to denote the existential quantification of the predicate, and the backwards, the kind of capital E, is to be read as there exists. So again, this existential quantifier, it can be understood again as a map from from predicative variables to propositional variables, and what it does now is it just kind of finds a singular value for which that predicative variable is true, right? So that's, this propositional variable, there exists an element in the domain of discourse such that P of x is true. That may be true or may be false, depending on what particular predicate I put in, but because it's a predicative variable, We don't know whether or not that statement is specifically true or specifically false. All we do know is that it must be either true or false. In other words, it's a propositional variable. So our final one to go to is the uniqueness quantifier, which is basically just a very kind of minor modification of the existential quantifier. In other words, we have a predicative variable, again, p of x, then the uniqueness quantification of p of x is the propositional variable. There exists a unique element in the domain of discourse such that p of x is true, and we use this notation, which is this backwards e with the exclamation mark, to x p of x to use this idea of there exists a unique. So the backwards e with the exclamation mark is the there exists a unique. So those are our three main quantifiers that we want to talk about. That was the universal quantifier, which ran over for all values of x, an existential quantifier, which just said that there exists a single value of x for which p of x was true, and the uniqueness quantifier, which said there exists a unique value of x for which p of x is true. So in each of these cases, we understand these quantifiers as maps or functions from predicative variables to propositional variables. And let's just look at some statements now, or some specific examples of statements that contain these types of things. And then let's see if we can formalize them now in the context of first order logic. So we have the statement, all humans are mortal, right? So this is a proposition or statement. And in propositional logic, it was not possible to formalize this statement. But in predicative logic, in first order logic, we can do that now. We want to identify what are the kind of properties and what are the objects, and then what's the predicate. So we can write this as, for all x, p of x, where p of x is the predicate, x is mortal, and the domain of discourse is all humans. So we use this notation, the kind of upside down a, x, p of x. So that's saying for all x, p of x, and then we need to kind of say what p of x is. P of x is the predicate, x is mortal, so when I put in particular values of x in there, that will be either true or false, depending on which things I put in. And the domain of discourse is all humans, so if I put in the only values that I can run x over are humans, and those are the only things that I can put into this predicate. So the next one we've got is, for every integer, there exists an integer, or for every integer x, there exists an integer y, such that y is greater than x. So this is an example of a predicate that contains two variables, right? We've got two variables, y and x, and we want to see if we can formalize that now in our kind of language of first order logic. So we've got first for every integer, so that means we're going to have something like a for all statement. So for all x, we've got there exists a y, and then we've got p of xy. So we need to identify what p of xy is. Well, p of xy here is going to be the predicate y is greater than x. So we've got here, this can be written in the following way. So we've got for all x, there exists a y, p of xy, where p of xy is the predicate y is greater than x. And if we put in particular values of x and y, we can see that might be true or might be false. But we need to also define what the domain of discourse is for both x and y. And we, in this case, take the domain of discourse for x and y as the integers. So if I put in this case, say the number 1, I can't put in numbers here because the statement is for every x there exists a y such that p of xy is true. So that means that if you hand me an x, if I say I'm given the number 2, then I can find a y in the integers such that that is bigger than 2. Well, that is indeed true, right? I could take 3. So in fact, this statement happens to be true. But again, to re-emphasize, that's not really the point. The point here was the fact that we can now formalize statements in the context of first order logic. So that's where we're going to conclude this video. And in the next video, what we're going to do is we're going to look at this idea of kind of negating certain types of predicative variables, or predicative variables that also contain these quantifiers, as well as introducing another notion of De Morgan's laws, but now De Morgan's laws in the context of first order logic and not in the context of propositional logic. So again, please engage with the written material that is on Moodle, as well as all the questions that can be found in the module handbook at the top of the Moodle page. So thanks very much, and see you in the next video.